Hey math kids, today I wanted to talk just really quickly about an application of complex numbers and imaginary numbers, because often I get questions like, why do we need to know this? Why does anybody use this? Like, is it useful at all? So I'm going to talk in the context of recording music. And when you record music, so let's say you have a guitar hooked up to an amp, and then you have a microphone trying to record the sound coming out of that amp, the placement of the microphone is really important. Now, obviously, we're not going to get into like exactly how to record a guitar, but sometimes when you place the guitar or the mic towards the guitar amp, it will cut out some frequencies. And really what's going on is some of the frequencies are perfectly out of phase with other frequencies, and that there's some like wave cancellation there. So if two waves are perfectly out of phase, they're going to create silence. So for example, if we have a sound wave and then we play a sound wave that is the exact same but opposite, what happens is we hear nothing. Okay? And where complex numbers come into this is if we find the equation of that wave. So let's say this one's sine x, and don't worry too much about sine if you've never heard of it. We'll actually learn about it later in this class. But it's just, it's an equation, y equals sine of x. Now, how much we move that to the left or the right can be described by complex numbers. And so we think of phase as a complex number. And so if we have two waves that are out of phase, perfectly out of phase, we get nothing out of that. So I just want to show you a quick demonstration of this, just for fun. Let's see. Okay, so I just have a music program. I have two songs. Well, it's the same song, but two versions of it. So I just have the normal song right here. I'm just going to play it. And we know that only one wave is turned on because it lights up when it's turned on. When I hit these buttons, I can turn them on and off. So nothing's turned on right now. But then I can do this. And there's a little bit of a delay if I'm playing it. Now, I'm going to play the inverted one. So with the inverted one, there's a function in this music program where you can invert a wave. Now, inverting a wave, if you just listen to it, it doesn't sound any different. Our ears really can't detect the difference between an inverted wave and a normal wave. So both those files sound the same, but one is inverted. Now, if I play them both at the same time, so notice how they're both turned on now, we should hear nothing. Okay, because they are perfectly out of phase, which once again is related to complex numbers. Phase is a complex number attribute of a wave. Now, if I turn this off and then turn it on, see how we can hear different parts of the song. So, you don't necessarily have to do anything with this information. This is just for you to see it and hear this in a real world context. Now, another thing that a lot of people do, especially with like electronic music where people are using samples, or DJs who just want like a vocal hook or like a vocal a cappella to use in some of their music, often what they'll do, so a lot of singles, when somebody releases a single, they'll often release a bunch of different versions of the song, and often one of those versions will be instrumental. Now, if you have like the regular version of a song that has instruments and singing in it, and then you have the instrumental version of that song, if you take that instrumental version and you invert it, then you play it alongside the version that has singing and instruments. You can cut out all, and maybe you can maybe cut out all of the instruments. You have to tweak the levels a little bit and play around with it. But in theory, you should be able to invert the instrumental song, play it next to the song that has singing and instruments, and it will completely cut out the instruments, and all you'll have is the singing. That way, if you want to do a remix of a song, you can have the original vocals, but you can create new music that goes behind it. If you want to do mashups, you may be familiar with those. Often that's how the artists get the a cappella that they use to make those. So if you want to chat more about this, you can come to Math Lab. But until then, calculator.